So बताओ भाई क्या पढ़ना है? Tell what you want to like study. So we were continuing our CRE last class, okay? CRE heterogeneous part we were continuing. So we have done. The heterogeneous part of the CRE is almost completed. Okay, just one two things are left. Very small. One two things are left. Your surface kinetics and like everything for your spherical pore diffusion. Okay, like we have done it for your pore diffusion. We have done it for your cylindrical pore. Okay, that is only there in our GET syllabus. Okay, so from spherical pore, question has not been asked, but still like for knowledge we will write down the formulas and understand about the cylindric about the spherical pore. Okay, because it is ISC Bangalore, no, so it may happen that they twist it something and they, instead of cylindrical pore, they give you a spherical pore. Okay, little bit changes will be there, that we have to see. And the next part left is your surface kinetics. Okay, so you tell me, you want to continue with your, we were scheduled to do your IPC revision. Okay, like IPC we were to complete. IPC is a small subject, okay, and it is not that much hard or conceptual also. It is a mathematical subject, so we will try to complete that IPC uh, in like first we thought that we will consider first I thought I will complete it in one day. Okay, but one day it will not be possible. Okay, like nothing gimmick is there, no, like one day I'll tell you and one day like just a very brief, there is no, like there will be no benefit of completing the course like that. Okay, we complete it in a little bit good manner only, so most probably by two classes our IPC will be over. Okay, so you want to continue with IPC or you want to do like you want to first complete the CRE and then move to IPC, that you tell. CRE heterogeneous part you want to complete first and then you want to continue with IPC, or directly you want to go with IPC? Sir, first CRE then IPC. And Jay is telling IPC kara do, sir. Jay, you were not joining the last classes, no? Was struck with college internship. Okay. Okay, no problem. You cover them in recorded format. I hope that you will be understanding the lectures. Okay, no problem in that. Still, if you have any doubt, you can ask in the group. सर 30 मिनट्स में CRE 2 खत्म कर दो, देन IPC में एंटर करते हैं. ओके ओके, let us continue with our CRE heterogeneous partner. Let us end it, or else it will be staying and it will be lagging behind. Okay, no need for that. Let us complete it and then we will go for our IPC. We will start our IPC. Okay, nobody's in that. चलो, तो CRE का हम लोग क्या कर रहे थे? हम लोग CRE we were doing it till we have done it till our that part, no? We want to do it for our spherical catalyst. Okay, if the pore diffusion in your spherical pore. Okay, so I'll tell you that. First, just write down the formula. I think the heterogeneous part is you have understood it. Okay, whatever was possible. See, our CRE is also over. So whatever was possible in this short span of time, I have delivered it. Okay, I don't know. Like I think this is the best thing, that in this much amount of time, this much is the best thing that I can deliver. Okay, not only I can, you can go and search anywhere. Okay, anywhere, like all big people who claim to be like a god of all these things, you can go and check anywhere. Okay, with your notes, you will not find a single thing extra. ठीक है, चलो ठीक है, अभी वो सब छोड़ो बात, वो सब डीलिंग बाजी का बात बाद में होगा. फॉर स्फेरिकल geometry, your epsilon, that is your effectiveness factor, is equals to 1 by 5 into 1 by tan h 35 minus 1 by 35. Okay, this you remember. For cylindrical, your epsilon was is equals to tan h 5 by 5, isn't it? And for your spherical geometry, your epsilon is equals to 1 by 5 into 1 by tan h 35 minus 1 by 35. Okay, you remember this. Okay. Now the second thing is, please understand, the second thing is that your diffusion or your pore diffusion in spherical geometry. Okay, pore diffusion in spherical geometry में क्या है भाई? The answer, so please clearly see it. So we reached it. This balance equation, that is your input minus output, will be is equals to your consumption. Okay, till here we have understood. Till here we have discussed it for the cylindrical also the same way. Till here we have already done it. Okay, so what will be the input? Your input will be again the same, that is minus dab into dou ca by dou z. Okay, at your z and into the area. Your output will be again minus dab into dou ca by dou z at your z plus dz into the area. Okay, these two things are already there. Okay, and your this, please understand this thing. Understand this thing. Okay, that in spherical what is going to happen is that, suppose you are having this sphere, no? So let us consider that at this point, that at r equals to 0, your reactant a is present. Okay, this will diffuse along the entire sphere. Okay, don't consider it to be a 2D geometry, consider it to be an entire spherical geometry, a 3D geometry. It is a sphere. So this concentration of a will diffuse it along the entire surface area. You getting it? No, a ball you have seen, no? So the entire ball through the entire surface area, this thing will occur. Okay, so what is the area, surface area in this case? It is 4 pi r square. Okay, it is 4 pi r square. That is the surface area of your sphere. Clear? And this is the surface area of your sphere. Okay, and what is going to happen is that, for this thing, for your spherical, this consumption, for your spherical geometry, this consumption, now you will not be able to define it with respect to that. Okay, for this you have to define your minus ra dash, into your this weight of catalyst. Okay, like this we will be defining it. You're getting it? No, as because the area is constantly changing, so for spherical geometry we will not be able to derive the equations with respect to your this thing, your surface area. So now we will be using our rate r minus ra dash. Minus ra dash means your mole per kg second. Okay, that is from this formula. No, this formula you have seen. No, that is minus ri dash is equals to 1 by w into dni by dt. Okay, from this thing we will be deriving it. So your weight of the catalyst is rho c, that is density of catalyst, into volume. This volume will be is equals to 4 pi r square and into delta r. Clear? This volume of the sphere that is constantly changing, it will be is equals to 4 pi r square, that is the surface area, and into delta r. Delta r means the distance from the center. This thing is clear, no? So your rate of disappearance, it will be actually, minus ra dash into rho c into 4 pi r square and into डेल्टा r. ठीक है, यहाँ तक आ गया. और ये जो यहाँ पे जो एरिया है, ये जो सरफेस एरिया है फॉर योर फ्लक्स, दिस सरफेस एरिया फॉर योर फ्लक्स विल बी सिंपली 4 pi r square. That is this surface area. This thing is clear. यहाँ तक क्लियर है कि नहीं बताओ? ठीक है ना? यहाँ तक क्लियर है ना? ठीक है, अब थोड़ा सा मतलब इसको अच्छे से लिख लेते हैं। तो ये क्या होता है ना कि सिलेंडर, फॉर सिलेंडर योर डिफ्यूजन एरिया, for cylinder your diffusion area we took it as pi r square, that is the cross sectional area. For sphere your diffusion area will be is equals to 4 pi r square, that is the surface area of the sphere. Clear? As because it is diffusing in the entire surface of the sphere. Okay, for this cylinder the reaction area that we took it as 2 pi r into dz, that is the curved surface area. But for this sphere we have to consider reaction volume, that is equals to 4 pi r square into dr. Okay, that is the basic difference that is being applied. Rest everything will remain same. You getting it? No, rest everything will remain same. Just this is the basic idea. And as because we are considering it reaction volume, so this minus Ra we will be defining it minus Ra dash, that is mole per kg second. Okay, and because this is kg, so this volume we have to multiply it with rho c, that is the volume of the sorry density of the catalyst, in order to like balance the rates. Okay, in order to balance the this thing, this kg, no, so the volume into density will make it a kg. So in order to make it mole per second, that is the molar rate, so we have to balance it out with the density. Okay, so this is your consumption. Chalo. Now let us apply it in the formula. So the formula was your input minus output is equals to consumption. So our input will be is equals to minus dab into dou ca by dou r at your distance let it be at a distance of r from the center. Okay, your output will be is equals to minus dab into dou ca by dou r at the distance of r plus dr. Okay, I hope you are getting it why we are considering it r, because we are going in the radial direction. Okay, इसमें भी r कर लो इसको, make this r only. Okay, as because we are going in the radial direction, so r and r plus dr. Okay, we have selected a particular small, like small spherical slit we have selected. This is a small spherical slit. Okay, that is having a thickness of dr and is at a distance of r from the center. Clear? That is the thickness of this small spherical slit is of dr and it is a distance of small r from the center. Okay, the basic ideas are clear only. Okay, like last lecture you see there that we have understood the basic lecture, that from here it will start diffusing, it will reach here along this small slit, the diffusion will occur. Okay, and the surface reaction will also occur, and it will come from here. So we are just balancing the fluxes, and we are saying that the loss in the flux will be equals to our consumption. So minus dab into dou ca by dou r at r, minus minus will make it plus. So dab into dou ca by dou r at r plus dr, that will be is equals to mm, that will be is equals to minus ra dash into rho c into 4 pi r square into dr. Okay, and also this will be multiplied, sorry, this will also be multiplied with the 4 pi r square, and this will also be multiplied by 4 pi r square. ठीक है, यहाँ तक क्लियर है? बताओ। यहाँ तक अगर क्लियर है तो इसमें कुछ करना नहीं है, अपने को DAB कॉमन लेना है, ठीक ना। यहाँ पे एक 4 पाई आर स्क्वायर लगा लो ब्रो, 4 पाई आर स्क्वायर विल कैंसिल आउट, सो यू जस्ट टेक योर DAB कॉमन, you will be getting dou ca by dou r square at r plus dr. Okay, minus dou ca by dou r square at r and divided by dr, that will be equals to minus RA dash into rho C into R square. Okay. Now here one thing is there. Here one thing is there that you have to keep in mind, that this R square, this is also a variable. This R square, this is also a variable. In the cylindrical, what was happening is that this cross-sectional area was constant. So this capital R was constant. So we took this R outside the like the derivation. Okay. But in this case, it will not happen. In this case, it is not the case. Getting it? No, what I'm trying to say. In this case, this small r is also a variable, so you have to keep this as a function. Clear? This is the main difference. You have to keep this as a function. This small r you cannot take it outside. So this will just become dab. This will just become dab into dou r of dou ca by dou r and into r square. Okay. This will be is equals to minus ra dash. Minus ra dash, let us put, no. It will just becomes, it will just become k dash into ca and into rho c into r square. Okay, it will become like this. Now this nothing you have to do, you just do the derivation. If you do the like the derivative, if you do it, so this will become dou square ca by dou r square into r square, and it will become dou ca by dou r into 2r. Okay, this will be is equals to k dash ca rho c into r square. ठीक है। अब इसके बाद इसको इसके ऊपर इसको हम लोग क्या कर सकते हैं, इसको हम लोग मान लो DAB बाई DAB इंटू आर स्क्वायर उससे डिवाइड कर देते हैं। ओके, सो दिस विल बिकम DAB इंटू डो स्क्वायर CA by dou r square. Let this cancel out this r square, and this will become 1r. Okay, so plus dou CA by dou r into 2 by r. ठीक है, this will be is equals to k dash into CA. Okay, from here you will be getting dou square CA by dou r square plus 2 by r into dou CA by dou r minus k dash CA by DAB equals to 0. ठीक, no need to proceed further. This much if you understood, then it's okay. Getting it? No, no need to proceed further कि CA का वो नहीं निकालना है, यहाँ तक कर लो, ये तुम्हारा governing equation. This will be your governing equation. Governing equation. Okay, this will be your governing equation. So this equation then you can solve and you can do it. ठीक है, इसको governing equation are you identifying? बताओ, ऋतिकेश, समुद्र, अमल, all you people are identifying which kind of equation this is? Can you identify which kind of equation this is becoming? Have you seen an equation like this? X square into d square y by dx square plus x into dy by dx plus y is equals to 0. Have you seen any equation of this kind? It is Cauchy's linear differential equation. Okay, it is Cauchy's linear differential equation. If you multiply this entire equation by r square, so you will be getting the same kind of equation. Okay, the solution of that will be very complex, so no need to, yeah, so no need to do that. Okay, but you remember that for spherical this much difference is there. Okay, this governing equation you remember, it is enough. Then as per they will give you the boundary conditions or something. If they give in the question, then by it you can solve it. Okay, the main thing is that you have to understand few things. The first thing is that what is the basic difference between your cylindrical pore and your spherical pore. This you have to understand. The diffusion area for this was pi capital R square, that where your r was equals to constant. However, the spherical, the diffusion area will be 4 pi r square, where your r is not constant. And because this r is not constant in this cylindrical, very easily we took the pi r square outside of this derivative function. But in the spherical you will not be able to take it directly outside, you have to keep it inside only. Okay, and that will just make your all the calculations, all these things a little bit complex, and you will get a governing equation of this format. Okay, this is the first thing. The second thing is that the second key point is that for the cylindrical you were defining your this consumption as minus ra double dash into the area of the catalyst, as because the area of the catalyst was constant. But in this case you will not be able to do it because the area of the constant catalyst is also variable, so you have to define it with the weight of the catalyst. Okay, for the weight of the catalyst you just define it as minus ra dash, that is mole per kg second, and then this rho c will be there and this volume will be there. Okay, यहाँ पे ठीक है ना? ठीक है, अरे रोसी था, इसमें रोसी भी डाल दो, इसमें एक रोसी भी डाल दो ना, ये रोसी भी होगा इसमें. Just put this rosi also here. ये clear है? The basic difference between the spherical and the cylindrical is clear. And just remember that for the spherical, the effectiveness factor is given by this formula. This formula directly you remember. No need to remember this derivation and all these things. Okay, those things are not required. Just this formula you remember the end result, and just remember that what are the basic differences between the spherical and the cylindrical. Okay, it is very important. Okay, in gate also in gate till now from spherical question has not been asked, but yeah, they may ask you. They may ask you. Okay, like they will not ask the for the entire derivation and all. Okay, but they can ask for some small concepts. No, small concepts, small basic concepts they can ask. Okay, like they can give you some boundary condition with the help of which maybe this equation is solved very easily. So if you know this equation, you will be able to do it. ठीक है, ये अपना इतना हो गया. Now from this, after this is your that was the last part. Okay, after this is your surface kinetics. Okay, before surface kinetics, one more thing I just wanted to tell you, that is one curve I wanted to discuss. ठीक है, तो एक सेकंड रुक जाओ, हम बता देते हैं. One curve I wanted to tell you. Yeah, you see this curve. Okay, this curve you can find it in the Levin's pill. Okay, and from in 90s one question came from this curve. Okay, what is this curve? Is this curve between epsilon and your this Thiele modulus. Okay, this curve is something like this. ठीक है, ऐसा kind of curve होता है. ठीक है, अब what is there in this curve is that, please understand that when your phi is greater than 4, in that case your epsilon is equals to 1 by phi. Okay, so let this phi be equals to 4. In that case your epsilon will be is equals to 0.25, that is nothing but 1 by 4. Getting it, no? This thing you are getting it, no? ये चीज समझ में आ रहा है ना? तो ये कर्व क्या करेगा ना, मान लो यहाँ पे तुम्हारा फाई का वैल्यू 4 है, तो इस 4 के कॉरेस्पॉन्डिंग with corresponding to this 4, what will be the value of your epsilon? Suppose this is your 0.1, this is your 1, and this is your 0.01, something like this is there. Okay, and just starting from 0.1. Okay, something here it is like 0.4, here it is 1. Okay, like this kind of things are there. Okay, so this thing you have to understand. This thing you have to understand that if the epsilon value is less than 0.25, okay, if the epsilon value is less than 0.25, then what is going to happen is that your phi value will be greater than 4. Okay, and this will mark your strong pore diffusion. Strong pore diffusion. Okay, so sometimes in the question, maybe it is directly said to you, this phi value is not given to you. Maybe it is directly said that your epsilon is equals to 0.2. Okay, so then how will you identify that it is strong pore diffusion or not? Okay, so please understand, if your epsilon is 0.2, then your phi is equals to 1 by epsilon, that is equals to 5. So this means phi is greater than 4, that is equals to 5. So this will fall under the region of strong pore diffusion. ठीक है, बस इसमें इतना ही समझाना था हमको. ओके, इतना ही समझाना था. ठीक है, इस टाइप का कर्व देखना एक आता है. ठीक ना, तो ये ऐसा जैसे 4 है ना, ऐसा 4 है ना, तो 4 के इस तरफ वाला जो पार्ट है वो तुम्हारा क्या हो जाएगा, स्ट्रॉन्ग पोर डिफ्यूजन हो जाएगा. स्ट्रॉन्ग पोर डिफ्यूजन. ओके, और 4 के इस तरफ वाला जो पार्ट है वो क्या हो जाएगा, तुम्हारा वीक पोर डिफ्यूजन हो जाएगा. Getting it, no? This is your Thiele modulus equals to 5, no? So region from this region, this region will be your strong pore diffusion, and this region will be your weak pore diffusion. Okay, this thing is there. And see, in this strong pore diffusion, what will happen? In this strong pore diffusion, is epsilon is equals to 1 by 5, no? So that means what? It is having a inverse relationship is there. So as the phi value will go on increasing, this epsilon value will be going on decreasing. Okay, as this phi value will go on increasing, this epsilon value will go on decreasing. So a inverse relationship is there like this. A negative slope curve will be there. Okay, a negative, like curve will negative slope only, but the tangent to the curve will also have a negative slope. Okay, so this is the main thing. Okay. Mm. So by seeing the value of your epsilon also, you can define that, you can decide that whether it is strong pore diffusion or it is weak pore diffusion. ठीक है, तो ये चीज अपना है। ये थोड़ा कर्व रहता है 11th फिल में, तो इसके ऊपर 90s में एक क्वेश्चन आया, वन क्वेश्चन केम फ्रॉम 90s बेस्ड ऑन दिस concept, so you can go and check it. Okay, you will be able to solve it now. Okay, so this much, or this was all about your heterogeneous. The only last part that is left, that is your surface kinetics. The only last part that is left, that is your surface kinetics. Surface kinetics. Okay, before doing that surface kinetics, I'll just give you a question, you try to solve it. Just one question I'll give you, you try to solve it. Okay, just 1 second. Chalo. Yeah, so right, the Thiel modulus for a first order isothermal reaction for a spherical geometry catalyst is found to be to calculate the catalyst effectiveness factor. Right, on the next question, that is a reaction A2R is to take place on a porous catalyst pellet. dP is equals to 6 mm, dE is equals to 10 power minus 6 meter cube per meter cat second. Okay, if the concentration of reactant bathing the particle is 100 mole per meter cube and the diffusion free kinetics are given by minus Ra is equals to 0.1 Ca square mole per meter cube of catalyst per second. The factor by which the rate slowed by pore diffusional resistance is dash. Yeah, solve these questions. सर थीले मॉडुलस एंड टेम्परेचर का कुछ रिलेशन है? होगा भी तो जरूरी नहीं है। होगा भी तो जरूरी नहीं है। बनाओ बनाओ भाई, जल्दी बनाओ, इतना टाइम नहीं है। राइट डाउन वन मोर क्वेश्चन। एक और क्वेश्चन लिख लो। अमाउंट ऑफ catalyst in kg needed in a packed bed reactor for 80% conversion of 1000 meter cube per hour of pure gaseous A, where your Ca naught is equals to 100 mole per meter cube. If the stoichiometry and rate are given by minus Ra is equals to 50 Ca divided by 1 plus 0.02 Ca mole per kg per hour, and your stoichiometry is A to R. Yeah, solve this one also. Hmm. Solve this question, then we will do our surface kinetics and our CRE will end, and we will start our IPC revision. Okay. One more thing. Just check. No, the Thiele modulus formula you know. No, for nth order. For nth order, the formula for your Thiele modulus you know. So just check once that what is the formula for your zeroth order, what is the formula for your second order. Okay, these two. Not much. Just first order you know already. So once check for your zeroth order, once check for your second order. Okay. The Thiele modulus formula. Just like once find it out and you know it. Okay. I'm not telling you to remember it, but once if you just remember it, it will be good. But because maybe a question comes directly, so if you remember the formula directly, you will be able to solve it. Okay, because from the first order they have given enough questions. Okay, so now again same concept. What question they will give? So maybe they just change the order of the reaction. They will give you for the zeroth order. They will give you for the second order. Like this, they may give you. Third one. What is the answer for the third one? डूइंग सर, बनाओ बनाओ। क्या आया हुआ है? या करेक्ट, करेक्ट करेक्ट। बताओ भाई, बाकी लोग नहीं बना रहे हो क्या? रेस्ट ऑफ यू आर नॉट सॉल्विंग और व्हाट? दीना राम। Ritikesh, send the solution for the second question. Send the solution for the second question. एक लड़का था भाई नमन करके, वो क्लास करता था पहले, अब नहीं क्लास करता है। ठीक है, देखो इधर, सी। So for the first question, it is said that the Thiel modulus for a first order isothermal reaction for a spherical geometry catalyst is found to be 2. So directly phi is given to us 2. You have been said to calculate the effectiveness factor. So just now we have written down the formula. It is 1 by how much? What is the formula? Just now we wrote it, no? 1 by 5, 1 by... Okay. It is 1 by phi into 1 by tan h3 phi minus 1 by 3 phi. Okay. In this equation, just put the value of your phi is equals to 2 and you will be getting your epsilon. So your epsilon will be is equals to 0.4167. Okay. Something like that we will be getting. Okay. Now see in the second question. In the second question, it is said that a reaction A to R is taking place in a porous catalyst pellet. Okay. dP is given to you as 6 mm. Okay. That means your diameter is given to you as 6 mm. क्या हुआ भाई? ऋतिकेश सेकंड वाले का सॉल्यूशन भेजो भाई. So your radius will be is equals to 6 by 2, that is equals to 3 mm. Okay, or you can write it as 3 into 10 power minus 3 meter. Clear? As because rest all other units are in meter, no, so it is better to convert this millimeter to meter, okay, at the beginning only, or else afterwards there may be some problem. Okay, this is your dab given. Your dab is given to you, that is your diffusivity is given to you as 10 power minus 6. Okay, this is meter cube per meter, so this will just cancel out, you will get in meter square per second only. Okay, this is just represented per meter catalyst, means this is just represented in that unit. Okay, don't be confused that okay this is meter cube, this is meter catalyst, what is the nothing. This is just meter cube per meter catalyst per second. Okay, so per meter catalyst and this meter will cancel out. This cat is not some unit, it is just denoting that it is the length of the catalyst. Okay, per meter of catalyst, like that. Okay, the concentration it is given to you as 100. See what is given, the concentration of the reactant bathing the particle. Bathing the particle means, suppose this is your particle and the concentration of the reactant bathing the particle means the concentration of this reactant just which is just at contact with the particle. Okay, suppose this is your contact, this is your catalyst, so the concentration of the particle of the reactant that is just with contact with the catalyst. Okay, that means it is given as your CAS. Getting it? No, your this line that is written, the concentration of the reactant bathing the particle, that means nothing is CAS is given. Your CAS means the concentration of the reactant that is just with contact with the catalyst surface. Okay, so your CAS, this is given to you as 100 mole per meter cube. Okay, what else is there? Your minus Ra is given to you as 0.1 into Cs square. Okay, so your K value it is given to you as 0.1. Clear? It is said the factor by which the rate slowed by pore diffusional resistance is dash. Okay, also check this unit. Also check this unit of your minus Ra. It is mole per meter cube per catalyst second. Okay, so that means what? That means what? This K value it is used. This K value is given to you. It is 0.1. It is not K dash or it is not K double dash. Okay, none of these are given. It is given your normal K value. Okay, so for this you know your Thiel modulus formula. No, your Thiel modulus is equals to n plus 1 into CAS to the power n minus 1 and into K and divided by 2 DE into L. Okay, LC or L anything, characteristic length or L anything. And as because it is a sphere, it is given a porous catalyst pellet. Sphere कहीं पे given नहीं है क्या? The reaction, porous catalyst pellet is given, no? See here, porous catalyst pellet is given, no? So generally the shape of this shape of this pellet is a spherical shape. Okay, like this kind of spherical shape is there and it is porous in nature. Okay, so you have to consider your shape to be spherical. Okay, this is your geometry. Okay. If it's a cylindrical pellet, then they will mention to you a cylindrical pellet. Okay. If it is not mentioned cylindrical pellet, then by default you consider your pellet to be spherical. Okay. Generally pellets are generally spherical in nature. Okay. So this is your spherical geometry. So then what you have to do is that just you have to put your n. So what is your n here? What is the order of the reaction? So the order of the reaction is second order. So n is given to you as 2. So you just put here n equals to 2, and this k value is already given to you, that is your 0.1. D is given to you as 10 power minus 6. Okay. And CAS is given to you as 100 mole per meter cube. LC will be nothing equals to, for spherical catalyst I already told you that your L will be is equals to R by 3. Okay. So R is equals to, I think it is 3 into 10 power minus 3. So L will be is equals to just 10 power minus 3. Okay. All these values you put, and you will be able to find out your thylomodulus. You will be able to find out your thylomodulus, that is your phi. Okay, once you find out your phi, so now see what is being asked. The factor by which the rate slowed by pore diffusional resistance is. Okay, so you know that the definition of your effectiveness factor is rate of reaction with pore diffusion divided by rate of reaction without pore diffusion. This thing you already know, no? This thing you already know, no? So now the factor by which this rate will be slowed, the factor by which this rate will be slowed is what? Nothing but this effectiveness factor. ये चीज समझ में आ रहा है? This thing you are getting it, no? The factor by which the rate will be slowed by the pore diffusion, this is your rate with pore diffusion. Okay, this is your rate without pore diffusion. So what is the factor by which it is getting reduced? Ra double dash into phi, sorry, Ra double dash into epsilon. This will be is equals to minus Ra double dash. So this is with pore diffusion, this is without pore diffusion. So without pore diffusion is getting reduced by a factor of this epsilon. Okay. This, the factor by which the rate is slowed is this epsilon. So this epsilon you have to find it out. So very easy. Once you have found out your this modulus, so directly apply your formula for your this thing. As far as the spherical geometry, you directly apply it. That is 1 by 10 3 5 minus 1 by 3 5. Done. This question is clear, no? The second question is clear, no? Most of you have solved only, but still, like if it is clear, it is clear, no? So few things are very important here. The first thing is that this thing. The first concept is that this, it is the reactant bathing the particle. So this will be nothing but the surface concentration. That is your CAS. Okay. And the second thing is that the factor by which the rate is slowed by the pore diffusion resistance. That factor is nothing but your this thing, uh, effectiveness factor. Okay. Because this effectiveness factor definition is only with pore diffusion divided by without pore diffusion. So without pore diffusion into effectiveness factor will give you the rate of the reaction with pore diffusion. So by the what factor it is getting reduced, it is nothing but your epsilon. ठीक है. Now come to the third question. The third question is very easy. It is a packed bed reactor. So packed bed reactor, I directly told you that you have to simply use the formula 0 to xa dxa by minus Ra. Okay. Or also you can do it in this way. W by nu naught into Ca naught is equals to integration of 0 to xa dxa by minus Ra. W by nu naught is equals to integration of this Ca naught dxa it will become. So you can write it as minus dca by minus Ra. Okay. And from Ca naught to Ca. Okay. So Ca naught is given to you in the question. What is Ca naught given to you in the question? Ca naught is 100 mole per meter cube. 100 mole per meter cube. Okay. This is your normal Ca naught given. So your Ca will be is equals to, at 80% conversion, 1 minus 0.8, that is equals to 20. Okay, because 80% conversion is given, no? It is given for 80% conversion, how much amount of catalyst is required. Okay. And your nu naught is already given to you, that is 1000 meter cube per hour. Okay. This is your nu naught given. And the rate is also mole per kg per hour. So no need to convert this into second or anything. Okay. Just check the units once. The rate unit is given in mole per kg per hour, and this is also given in meter cube per hour. Okay. These things are there. So both in both the units R is there, so no need to change the time units. So directly you can apply your formula and you can solve it. So this will be W by nu naught is 1000 that is equals to integration of 100 to 20 and minus dCA divided by minus RA. What is the value of your minus RA that is given? 50 CA divided by 1 plus 0.02 CA. Okay, I will not do the integration. Integration part you do it on your own. You just answer me one question, that this is given as a gaseous phase reaction. This is given as a gaseous phase reaction. A pure gaseous A is given. So a gaseous phase reaction is there, but we are solving it like a liquid phase reaction only. We didn't consider your epsilon. Why? Why? Hmm? Why we did it like this? Here we got Ca naught into dxa, no? This Ca naught into dxa, we wrote it as minus dca. How we could write it? This is only possible when your Ca is equals to Ca naught into 1 minus xa. From here, your minus dca will be equals to Ca naught into xa. But this is only case for your CVRS, no? And CVRS means we know that it is a liquid phase. But in this question, it is given gaseous phase. So how we could apply this? बताओ. हाँ, correct, correct, correct. The only correct, correct, correct. Okay. The only reason behind this is nothing. We have applied the formula for our VVRS only. We have applied the formula for our VVRS only. That is our Ca is equals to Ca naught into 1 minus Xa divided by 1 plus epsilon A Xa. We have applied this formula only as because it is given VVRS. But the problem here is the stoichiometry of the reaction. It is just A to R. And from here your epsilon will be nothing but 0. As because your epsilon is equals to 0, so this part will have no effect. So it will, the formula for your CVRS and VVRS will become equal. ठीक है. अगर लेकिन स्टोइशियोमेट्री इक्वल नहीं होता तो हम लोग इसको अप्लाई नहीं कर पाते. प्लीज कीप दिस इन माइंड. इफ दिस रिएक्शन द स्टोइशियोमेट्री, this the sum of the coefficients of your this reactant side and your product side, it would have been not equal. That means this reaction is something, a gives 2R. Okay, in that case you would have not been able to do it. Please keep this in mind. In that case, your epsilon will be is equals to 2 minus 1 by 1 into ya naught. So it is given pure gaseous here, so ya naught is equals to 1. So your epsilon will be like this. Okay, these things we have already discussed in your VVRS reaction, but still I just wanted to check. ठीक है. No need to think it like this, that it is a catalyst reaction, it is a heterogeneous part, so there will be no concept of CVRS and VVRS. No, your concept of CVRS and VVRS will be there. If it is mentioned gaseous phase, then you have to consider it to be VVRS. The only thing that saved us here is that the stoichiometric coefficients on both the sides were equal, so our epsilon value came out to be equal as 0. Okay. अगर ये zero नहीं होता, if this value would not have been zero, then we would have considered this formula only, and in that case, our integration would become a little more complex. Nothing else. It would have easy only, a little more complex. ठीक है. Directly we couldn't have write this thing. This part is clear or not? इतना बताओ, इतना clear है कि नहीं? जल्दी लिखो भाई, दीनाराम. टाइप किए जा रहे हो. Is how to identify whether given catalyst is spherical or cylindrical. It will be mentioned in the question. Whether the given catalyst is cylindrical or spherical, it will be mentioned in the question. Okay, don't be worried about that. In GET, it will be clearly mentioned whether it is a cylindrical catalyst or it's a spherical catalyst. Don't be worried. ठीक है. चलो. अब let us come to the last part, that is your surface kinetics. Questions enough we have solved. This kind of questions only you will be finding in your GET exam. Okay, you go and check all questions, you will be able to solve it. Let us come a little bit forward and let us solve our surface kinetics. Let us understand what is our surface kinetics, and then our this CRE will be over. Then we can start our IPC. Okay. So surface kinetics. Okay. So what is this surface kinetics? Nothing is there. Okay. Very easy. What it actually means is that, okay. So two mechanisms are there. Please understand. Two mechanisms are there. One is your Langmuir Henselwood, and the other one is your Euler riddle. ठीक है. इसको बहुत अच्छे से समझ लो. Please understand it very carefully. Nowhere it is given clearly. Okay. So please understand this very carefully. You will be able to solve all the questions. Okay. So let us understand one by one what is actually happening. Okay. Let us start with Langmuir Henselwood. Okay. Actually, in Langmuir Henselwood, what is happening is here your A is present in your gaseous phase. Okay. What is happening? Please understand. Suppose this is your catalyst. Okay. In this catalyst, what is going to happen is that there will be some sites or active sites, which is also known as your what we call it as vacant sites. Okay. In this catalyst, what is going to happen is that there will be certain vacant sites. Okay. Now, in these vacant sites, your reactant will get adsorbed. Okay. After the reactant is getting adsorbed in this vacant site, it will participate in a reaction and it will produce a product. Clear? You're getting it what I'm trying to say? In these vacant sites of the catalyst, your reaction is going to your reactant is going to get adsorbed. Once it gets adsorbed in that on the vacant sites of the catalyst, then it is going to participate in a reaction and it is going to get converted into your product. Okay. Now, many things can happen. There are many possibilities. What are the possibilities? It may happen that suppose we are considering two reactants, okay, A and B. Two reactants are there and one product is there, that is your P. Okay, or let it be C. One product is there. This is our overall reaction. It may happen that your A is adsorbed, your B is also adsorbed, and the product C that is formed, it is also in your adsorbed phase. This is one possibility. What else can be there? It may happen that your A is adsorbed, but your B stays in gaseous phase only, and they react, and the product C that is formed, it is also in gaseous phase. Or it may happen like this also, that your A is adsorbed, your B is adsorbed, and the C is in the gaseous phase. Product C is in the gaseous phase. So all these things can be possible. Okay. So how to apply these mechanisms in all these possible cases? Let us understand. Okay. For one basic case, we will do the derivation, and then after that you can do it on your own only. Okay. For the rest of the cases, that from a very small trick I will give you. The derivation I am doing it because in 2023 one question came where this derivation part became important. Okay. If this derivation you will not know, then that 2023 question you will not be able to solve it. Okay. So that's why we will do the derivation little bit. Okay. And then we will apply some trick. I will tell you a trick, by that you will be able to solve. No need to derive it every time. Okay. So see here. In Langmuir Hinselwood, what is going to happen is that your A, that is your reactant, it is going to be present in your gaseous phase, but it is going to get adsorbed and form AS. Okay. This S is nothing. This S is just denoting the site. Okay. This S is just denoting the site, and this AS, this is just denoting the A is adsorbed on a site. This thing is clear, no? This S is nothing but a site, and this AS is nothing. It is just A adsorbed on a site. Clear? That means A was present in a gaseous phase, and then A came in contact with a active site, and it got adsorbed on that active site, and it formed your AS. Okay. The forward reaction rate constant, let it be Ka AD, that is your adsorption, and the backward, let it be Ka D, that is your desorption. Clear? Similarly, let your this thing, your B is also in gaseous phase. It is also getting adsorbed. So this will be KBAD, this will be KBDE, and this will form your BS. Clear? Then your AS plus BS, that is your A adsorbed plus your B adsorbed, will react together and it will form your product S plus one vacant site. Okay. And finally, this product S, it will get dissolved and it will become your product gas. Clear? So what is your overall reaction? Your overall reaction is A plus B gives your product. Okay. However, the mechanism is that your A will also get adsorbed, your B will also get adsorbed. This thing is clear, no? The mechanism is your A will also get adsorbed and your B will also get adsorbed. Okay. And this mechanism only where both the reactants are adsorbed. Both the reactants are adsorbed. This mechanism only is your Langmuir-Hinshelwood. Okay, this is only called as your Langmuir-Hinshelwood. So in Langmuir-Hinshelwood, what is going to happen? Your both the reactants that are going to be present in your gaseous phase initially, but they are going to get adsorbed on the surface of the catalyst, and then they are going to participate in the reaction. Okay, in Allen-Riddle mechanism, what is going to happen? Your one reactant is going to get adsorbed, the other reactant is going to stay in the gaseous phase. That is the simple, basic difference. Okay, in Langmuir-Hinshelwood, what is going to happen? Both the reactions are going to get adsorbed. However, in Allen-Riddle mechanism, what is going to happen is that one reactant will be adsorbed and the other reactant will be in gas phase only. It will not get adsorbed. Okay, so this is the basic difference. यहाँ तक clear हुआ? Till here it is clear? यहाँ तक clear है कि नहीं बताओ? ठीक है. If till here it is clear, then let us do the derivation. That how we will do the derivation and all these things. Okay. So what we said is that your rate, okay, please one thing understand. We define here two quantities. Okay, one quantity is your theta A, the other quantity is your theta B. Okay, what is your theta A? What is your theta B? Your theta A is fraction of sites taken by A. Okay, what is this theta B? This is fraction of sites taken by B. What I'm trying to say is that suppose on this catalyst total 10 sites are there. Okay, out of these 10 sites, let us say that 3 A is getting absorbed on 3 sites. Okay, so then what is your theta A? Your theta A will be 3 by 10. That is the fraction of sites that is taken up by A. Okay, and suppose 4B is getting absorbed on 4 of these sites. So then what will be your theta B? That will be 4 by 10. That is your 0.4. That means this much amount of fraction of sites has been taken by B. Clear? So now what is the fraction of your vacant sites? What is the fraction of your vacant sites? Your vacant sites will be 1 minus theta A minus theta B. So this will represent your vacant sites or sites available for adsorption. This thing is clear. ये चीज क्लियर है कि नहीं बताओ. Your theta A is fraction of sites taken up by A. Your theta B is fraction of sites taken up by B. So your 1 minus theta A minus theta B, that will be the fraction of the vacant sites, or vacant sites means the sites that are now available for your adsorption for further of A or B anything. Clear? No, these vacant sites, this is only available for the adsorption. Now either A can be adsorbed on it or B can be adsorbed. That is not the matter. But these are only available for adsorption. Okay. From this example also, hmm. From this example also you can understand it. Okay, what I said, the total number of sites is equals to 10. So 3A is getting adsorbed on 3 sites, so theta will be 3 by 10, and 4B is getting adsorbed on 4 sites, so theta B will be equals to 4 by 10. So what is the fraction of the vacant sites? What is the fraction of the vacant sites? It will be 1 minus 0.3 minus 0.4. That is equals to 0.3. So this much fraction of vacant sites are available. ठीक. So now please understand that how do we start the derivation. Okay. कहाँ गया? So your first reaction was A in gaseous phase plus a vacant site. Your forward rate constant is KAAD. Backward is KADE. This is giving you AS. Okay. So rate of adsorption of A will be given as KAAD into 1 minus theta A minus theta B and into PA, partial pressure of A. Okay. Your rate of desorption of A will be is equals to KADE into 1 minus, KADE into your theta A. Okay. Why this is coming as theta? Now let us understand. So rate of absorption, we are defining it as rate constant into your fraction of vacant sites into your partial pressure of A. Okay. The rate of desorption will be defined as the rate constant and into the fraction of size that has been occupied by A. Because from the fraction of size that has been occupied A only the desorption can happen. No, desorption means what? That your A is already present. It will now remove, like get removed from it. It will now leave it. It will get dissolved from it. So this desorption can be possible only from the point where your A is present. No, getting it? No, your desorption is possible from only from the sites where your A is present. So in case of desorption, you take it as KADE into theta A. Okay. Now what you have to do is that you have to consider it to be a steady state operation. A steady state operation, or also you can consider it at equilibrium. Okay. So at equilibrium, what is going to happen is that your forward reaction rate and your backward reaction rate are going to be equal. Okay. So that means your rate of adsorption of A is going to be equal with rate of desorption of A. So what you're going to get is here KAAD into 1 minus theta A minus theta B into PA. It is going to be equal to with KADE and into theta A. Okay. From here, what you have to do is that you just find out this value of this thing 1 minus theta A minus theta B. This will be is equals to KADE divided by KAAD and into theta A by PA. Clear? Also, you do one thing. You write it as Ka is equals to Ka adsorption divided by Ka desorption. Okay. So this Ka AD by KAD, you write it as capital Ka. Okay. So this you will be getting it as your, like this thing will simply become theta A by Ka PA. Okay. This will be equals to your 1 minus theta A minus theta B. So all these things we did it for your A. Okay, for A. Same thing you do it for your B, because your B is also getting adsorbed, no? So your B, sorry, your B. The first one I'm doing it in detail. Okay, the later one I will not do it that much detail. You can understand it on your own only. So B plus A, it will give you BS. This will be KBAD. This will be KBD. Okay. Generally these things are not very much clear, so I'm doing it in detail. ओके, क्योंकि इसको क्या है ना, इसको क्या बोला, हर जगह ये नहीं मिलेगा, तो इसलिए थोड़ा सा डिटेल में बता देते हैं. सो सेम रेट ऑफ एड्सॉर्प्शन ऑफ डी ऑफ बी, ये क्या हो जाएगा, रेट ऑफ एड्सॉर्प्शन ऑफ बी क्या हो जाएगा, के बी ए डी इंटू अगेन द वैकेंट साइट्स एंड इंटू पार्शियल प्रेशर ऑफ बी. रेट ऑफ डिसॉर्प्शन ऑफ बी, it will be again kb de into theta b, again for same thing at equilibrium both of these will be equal. Okay, so just equate them. KBAD into 1 minus theta A minus theta B into PB will be is equals to KB into DE into theta B. Okay, from this you just again find out this value of 1 minus theta a minus theta b. It will be is equals to your theta b divided by kb pb, where again your kb is nothing but kb adsorption divided by kb desorption. Okay. Now what you have to do is that this one equation you have got and this one equation you have got. From both this equation, 1 minus theta a minus theta b, 1 minus theta a minus theta b. Both these values you equate it. Once you equate it, you will get theta a by ka pa will be equals to theta b by kb pb. Okay. Now your job is to just substitute a particular value. Okay. Suppose you substitute your theta b to be equals to ka pa divided by kb pb into your theta a. Okay. You just substituted the value of your theta b. Okay. Now put it in any of the equation. Put it in any of the equation. Okay. Put it in any of the equation means what I'm trying to say is that you can put it in any of the equation. Okay. Like what was the first equation? It was 1 minus theta a minus theta b is equals to theta a by ka pa, no, by ka pa, no. This was the first equation, no. Here just put the value of your theta b. So 1 minus theta a minus, in place of this theta b you put it here, this thing ka pa divided by kb pb and into theta a. Okay, this will be is equals to theta a by ka pa. Okay, from here you find out the value of your theta a. So your theta a will be equals to 1 by ka pa plus 1 and plus ka pa divided by kb pb. ठीक है, ऐसा टाइप का आ जाएगा। कुछ गलत कर दिए है, 1 सेकंड 1 सेकंड। दिस थीटा भी हाँ, यहाँ पे गलत किया है ना। तुम लोग बोल नहीं रहा है यार, गलत हो जा रहा है। इसमें तुम्हारा हो जाएगा केबी पीबी बाई के पी ए, ये ऐसा हो जाएगा। ठीक है, तो एक सेकंड, इसको भी वो कर लो। ये थोड़ा सा बोरिंग है, ठीक ना, थोड़ा सा इट इज लिटिल बिट ऑफ बोरिंग पार्ट इज देयर, बट यू हैव टू नो इट बिकॉज इन 2023 the directly they gave a question from this derivation only. Okay, I'll solve that question now. Don't worry, after I explain it I'll solve it. Okay, so this will be is equals to theta a and you will be getting ka pa here, so 1 plus ka pa plus kb pb. Okay, this will be is equals to your 1. So your theta a will be is equals to ka pa divided by 1 plus ka pa plus kb pb. Okay, so what was your theta b? Your theta b was equals to theta a into kb pb divided by ka pa. So put the value of your theta a, you will get your theta b to be equals to kb pb divided by 1 plus ka pa plus kb pb. ठीक है, this will be your theta b. Once you have found out the value of your theta a and value of your theta b, all you have to do is that you have to write the rate of the reaction. Your rate of the reaction will be nothing but equals to k double dash into theta a into theta b. Okay, this will be your rate of the surface reaction. Why this will be your rate of the surface reaction? Please understand, this will be rate of your surface reaction because theta a is representing the sites that are already having a, theta b is representing the sites that is already having b, and your reaction is as plus bs, is the sites which has already a is adsorbed, that is your theta a, and the sites where already b is adsorbed, that is your theta b. Okay, so that's why your rate of the reaction is k double dash into theta a into theta b. Okay, now nothing you have to do, you have to just put in the values of your theta a and theta b. What is the value of your theta a? Ka pa. What is the value of your theta b? Kb pb. And in the bottom you are having 1 plus ka pa plus kb pb whole square. Yeah, whole square will be there. Why you are getting whole square? You're getting it, no, because this one 1 plus chalo, बेकार में स्टेप जंप करके क्या होगा, ये ऐसा हो जाएगा। ठीक है, इससे क्या आ जाएगा, के डबल डैश इंटू के ए पी ए इंटू के बी पी बी डिवाइडेड बाई 1 प्लस के ए पी ए प्लस के बी पी बी होल स्क्वायर। क्लियर? दिस थिंग इज क्लियर? बताओ। दिस डेरिवेशन इज क्लियर और नॉट? ठीक है, so what are the steps? Nothing, the steps are nothing. Okay, Amal, you do one thing, no, you see the one kind of this kind of question has came in your 2023 gate. You send the question in the group, no? One question based on this has came in your 2023 gate. You take the screenshot and you share the question in the group directly from the question paper, original question paper. Okay, yeah. So what we have done, let us just see it. So we say that our language Hinsel-Wood mechanism will be that both our reactant will be in our adsorbed phase. Okay, if the both of the reactant in our adsorbed phase, so first we defined our theta A, theta B, then we defined our vacant sites. Theta A is the fraction of size that is taken up by A. Theta B will be the fraction of size that is taken up by B. So the vacant size will be 1 minus theta A, theta B. Okay, you can say it as fraction also or directly as the sites also. Okay, these things doesn't matter. Okay, then you defined it for the this thing for A, the rate of adsorption you define, the rate of desorption you defined. Okay, from these two rates, you said that at equilibrium, both of these rates will be equal. So from there, you find out the like one thing from that you get one equation. The second equation you got by applying the same balance for your B. From these two equations, what you do is that you find out the value. Two equations are there and two unknowns are there. That is your theta A, theta B. So you solve them and you find out the values of your theta A and your theta B. Once you found out the values of your theta A and your theta B, your reaction rate of reaction will be nothing, just K double dash into theta A into theta B. Okay, because this is only your reaction, no? This is only the reaction that is happening. Okay, ps plus s. Okay, this is only the reaction that is happening. So the concentration of this thing, concentration of this thing, both things multiplied and with k double dash. So this thing, now you put here the value of your theta A, value of your theta B, so you will get your minus ra double dash to be like this. Okay, in L-Radel mechanism what is going to happen, this thing is clear, no? In L-Radel mechanism what is going to happen, simply if you want to see, hmm, suppose simply you want to see the L-Radel mechanism now. Okay, क्या स्पेलिंग होता है, स्पेलिंग you check. Okay, in LRL mechanism what is going to happen is that your A gas is going to get adsorbed and it is going to form your AS. Okay, this AS is directly going to react with your B gas. Okay, B will not be adsorbed. I said you, in LRL mechanism only one reactant is going to get adsorbed. Okay, and it will form your product that is in the adsorb phase. Okay, this product then in turn again it will get into your gaseous phase and you get your site vacant. Okay, so this is the basic idea of your additive mechanism. Okay, in this additive mechanism what is going to happen is that your minus ra, this is your reaction step, will be is equals to k double dash theta a into pb. Okay, as because why this theta a, because a is adsorbed. Why this pb, because b is in gaseous phase. Gaseous phase. Okay, so our only job is to find out this value of your theta a. Okay, the only job is to find out the value of your theta a. So very easy. Finding the value of the theta is very easy. How it will be very easy? See here, this as, sorry, this a plus s will give you your as. This is your kaad. This is your kade. Okay, so what is your rate of adsorption? What is your rate of adsorption? That is equals to kaad into your vacant. Amount of vacant site available, that is 1 minus theta A and into partial pressure of A. Okay. Why we are not subtracting your theta B here is because there is no B adsorbed, no. So there will be no sites that is occupied by your B. Clear? There is no site that has been occupied by your B. So that's why we are not considering our theta B here. Okay. And our rate of desorption, that will be is equals to KADE and into your theta A. Okay. So now just equate them at equilibrium. If you just equate them, you will be getting KAAD 1 minus theta A PA will be equals to KADE into theta A. From here, you have to just find out the value of your theta A. Okay. Your theta A will be equals to KAPA divided by 1 plus KAPA. Okay. Where again, your same thing, your KA will be equals to KAAD divided by KADE. Once you have found out the value of your theta A, your minus RA will be equals to K double dash into theta A. In place of theta A will be this thing, and into you will be getting your PB. So this is the final answer. K double dash KAPA into PB divided by 1 plus KAPA minus RA double dash. Done. Clear? This thing is clear. ये चीज clear हुआ? Now let us summarize it. Okay. This derivation you have to understand it. Okay. You have to understand this derivation. Okay. This concept of this derivation, no, that your vacant site, rate of adsorption, rate of desorption at equilibrium, equating both of these to find out the theta A, theta B. Okay. All these concepts must be clear to you. But at the end of the day, we will just summarize it and we will just write down a trick. Please understand it. I'm just writing down the trick. Okay. ये पूरा clear है ना? Derivation is clear, no? Again, I'm asking. This entire derivation is clear, no? Okay. If the derivation is clear, then just write down the trick what I'm saying. Okay. So one is your Langmuir Hinselwood. The other one is your एले रेडल. क्या है स्पेलिंग? थोड़ा सा स्पेलिंग देख लेना, ठीक ना? इसमें क्या है? बोथ रिएक्टेंट्स एडजॉर्ब्ड. इसमें क्या है? ओनली वन रिएक्टेंट एडजॉर्ब. ओके. Now minus RA will be is equals to K double dash. This is, let it be double dash into theta A into theta B. This theta we will represent when the reactant is adsorbed. Okay. If only one reactant is adsorbed, okay, this PB is when the reactant is in gaseous phase. If it is adsorbed, you will consider theta. If it is not adsorbed, you will consider P. As simple as that. You are getting it, no? What I'm trying to say, you are getting it, no? Suppose you are having three reactants, A, B, C, or four reactants, A, B, C, D. Suppose A is adsorbed, B is adsorbed, and your C is not adsorbed, and your D is not adsorbed. So what will be your minus Ra double dash? What will be your rate of reaction? It will be K double dash into theta A into theta B into PC into PD. The reactants which are not adsorbed will be written as partial pressures. The reactants which are adsorbed will be written as their theta A and theta B. The concentration of the vacant sites, or the concentration of, sorry, not the vacant sites, the concentration of the sites that they have adsorbed or they have occupied, the concentration of the sites that they have occupied. If it is adsorbed, if the reactant is adsorbed, you will represent it in the reaction rate as the concentration of the sites that they have occupied. And if they are not adsorbed, they are present in the gaseous phase only, you will just simply represent it with their partial pressures. ठीक है. Suppose four reactants were there. Clear? As because in this Langmuir Hinsel wood, as because in this Langmuir Hinsel wood, in this Langmuir Hinsel wood, as because this is both the reactants are adsorbed. So in that case, what is going to happen is that your minus Ra double dash will be is equals to KAPA KBPB divided by 1 plus KAPA plus KBPB whole square. A whole square will be there. But in this LRL mechanism, only one is adsorbed. So minus Ra double dash will be is equals to K double dash into KAPA into PB and divided by 1 plus KAPA. Okay. Remember, in both of these cases, our C is not adsorbed. Not absorbed. That means suppose we are rewriting it for the reaction A plus B gives to C. So then C is not absorbed. What is our C is also adsorbed? What if our C is also adsorbed? The product is also present in your in their adsorbed phase. Then what will happen? For Langmuir Hinsel wood, it will just simply be K double dash Ka Pa Kb Pb. Remember, in the numerator you will only have the reactants 1 plus Ka plus KBPB plus KCPC whole square. And for the adder mechanism, it will be K double dash KAPA into PB divided by 1 plus KAPA plus KCPC. Clear? Now is it clear? If your product is adsorbed, just add it in the denominator as plus KCPC, as plus KCPC. In the numerator you will be only having your reactants. Okay. If the reactant is adsorbed, then you have to represent it by theta a, and this will be nothing but KAPA by 1 plus this entire thing. Okay. It will depend. If only A and B is adsorbed, then it will be 1 plus KAPA plus KBPB. Okay. If the product is also adsorbed, then just add your 1 KCPC. Okay. Both the cases. In this case also, your theta a will be equals to KAPA by 1 plus KAPA. Okay. But B is not adsorbed, so KBPB will not be there. C is adsorbed, so 1 by KCPC. Okay. Simply in this case, electrical mechanism, as your B is not adsorbed, so you have to multiply it with PB. In this case, your B was also adsorbed, so you have to again write your theta B. That will be equals to your KBPB divided by 1 plus all the components that are adsorbed. That is 1 plus KAPA plus KBPB plus KCPC. So you will be getting a whole square at the bottom. In electrical mechanism, no whole square at the bottom. ये समझ में आया? बताओ. इतना जो ट्रिक्स वो सब बताए. Sir, if C is adsorbed in the reactant, the KCPC will be in the numerator and the denominator for A plus B plus C gives D. Huh? Yes, of course. Of course, of course, of course, of course. Let us see. What he is asking is, suppose your reactant reaction is like this: A plus B plus C is giving D. Okay, this is our reaction. Okay, suppose this reaction, two methods we can write it: Langmuir, Hinselwood, and La Redel. Okay, two methods can be there. Okay, अंदर लैंग्वेज सी बहुत बहुत बढ़िया से देख लो, इसमें सब कुछ क्लियर हो जाएगा. अंदर लैंग्वेज हिंसेलमुड अगेन टू केसेस विल बी देयर. फर्स्ट केस इज दैट D is not adsorbed, that is your product is not adsorbed, and the second case is that D is adsorbed. Okay, now see what I will be writing. I will directly be writing minus Ra. Minus Ra double dash will be is equals to K double dash into KAPA KBPB KCPC divided by 1 plus D is not adsorbed, so 1 by KAPA plus KBPB plus KCPC whole cube. Whole cube. Why whole cube? Because minus Ra double dash will be is equals to K double dash theta A, theta B, theta C. So 3 will be there. So whole cube will come. If D is adsorbed, then minus Ra double dash will be is equals to K double dash into KAPA, KBPB, KCPC divided by 1 plus KAPA plus KBPB plus KCPC plus KDPD whole cube. This is for your language Hinsel-Wood mechanism. Clear? For your L-Radial mechanism, what will happen? Your L-Radial mechanism can be again of two types. Okay, and also here many things can be there. Okay, we are considering that let A be adsorbed. We are considering that only our A is adsorbed and B and C they are not adsorbed. Not adsorbed. Okay, this case also can be there. Or we can also consider one more case. What is that case? Suppose your A is adsorbed, your B is also adsorbed, but your C is not adsorbed. And both of these cases, in turn, will have again two cases. One is D adsorbed, D not adsorbed. One is your, in this also two cases. One is your D adsorbed and D not adsorbed. Okay. So let us see. Let us see how we will be writing. Let us see how we will be writing. थोड़ा सा ले लेते हैं. Okay. For D adsorbed, your minus Ra double dash will be is equals to only A is adsorbed, so K double dash KAPA. B and C are not adsorbed, so directly PB, directly PC. Okay, divided by 1 plus D is adsorbed, so KAPA plus KDPD. Okay, if your D is not adsorbed, in that case, what will happen? Your minus Ra double dash will be is equals to K double dash. Only A is adsorbed, B and C not adsorbed. So KAPA, and in place of B, directly PB, in place of C, directly PC, divided by 1 plus D is not adsorbed. So only KAPA. Done. Suppose you are having this thing. Two of the reactants are adsorbed, only one is not adsorbed. Okay. So in this also, if D is adsorbed, so then minus Ra double dash will be is equals to K double dash. A is adsorbed, okay. So KAPA. B is adsorbed, okay. So KBPB. C is not adsorbed, okay. PC. 1 plus KAPA because A is adsorbed. B is adsorbed, so KBPB. C is not adsorbed. However, D is adsorbed, so plus KDPD and one whole square because two reactants have been adsorbed. Two reactants are adsorbed, so whole square. What if D is not adsorbed? In that case, minus Ra double dash is equals to K double dash. A is adsorbed, okay, KAPA. B is adsorbed, okay, KBPB. And C is not adsorbed, directly PC. Divided by 1 plus A is adsorbed, so KAPA. B is adsorbed, so KBPB. But here no D is adsorbed, so directly this whole square. This thing is clear or not? ये जो पूरा सिस्टम लिखा हुआ है, ये चीज क्लियर है कि नहीं है, ये बता दो. Dinaram, I think this solves your doubt. So this was all about your surface kinetics. Okay. Now I think you just go and try to solve all the questions of your PYQ. You will be able to solve them like just like what to say in directly you will be able to write the answer. That is the part of your deactivation of catalyst. Okay. That is not a part of these things. That we can discuss once our syllabus is over and we do the topic of your deactivation of catalyst. At that time we can indulge in that. Okay, now it is not needed. Now till here, you know. Okay, based on this, you will be able to solve your previous year questions, and maybe like from here only the question next year also comes. Okay, because your deactivation catalyst of of catalyst and this enzyme kinetics, from there no question, like the only 3 years it has been added. Okay, so now no need to invest time in that now. Okay, first let us syllabus complete our main syllabus, the main important syllabus, then we can do all these things. No, how much time it will take. Okay, let us complete our main syllabus, then we can focus on all these things. All the extra things we can focus on later on, but first the backbone, let us complete it. No, why to invest time there? Anyways, we were about to do our IPC revision, but we didn't. We are in this only. Okay, we should have been doing our IPC revision, but instead of that, we are in this only. Okay, so anyway, some of our time is getting wasted. Not wasted. We are learning. Okay, this is also very important. Okay, but we are behind our schedule. No. Okay, so we will just solve this question and we will end the class today. Okay, I think today enough of we are done. We have done CRE, the entire heterogeneous part we have covered today. Okay, so any of you who wanted, if you want to learn the CRE heterogeneous part, no, you just covered today's lectures. Today's two lecture is there. So these two lectures you do, you will be able to solve all questions, 100% of the questions of your heterogeneous part. Okay, and with this we have ended our CRE subject also. So our mass transfer is over, our CRE is over. So tomorrow we will schedule a class for our IPC revision. Okay, very sorry if you were expecting it today, but this thing took a time. Okay, and like if we are doing something, then it is better to complete something. No, why to keep it halfway? There is no benefit. No, after give it so let us complete at least for if now question comes from these topics, then you will be able to solve it 100%ly. Okay. Okay, let us see the 2023 question. Why I invested this time in these derivations and all? You will understand it now. Okay, like before 2023, no, these derivations of this Langmuir, Hinselwood, and this Eller, it was not that much important. Okay, like directly they would give some cases and directly it was said to write these things. Okay, so if you just know this trick, you would have written it. But this derivation, no, now it has become important. Why in 2023 they gave a very good question. Okay, like very few good questions were there in 2023, and this one is one of them. Okay, I'll just show you the question. One second. Hmm. See this question. बनाओ इसको, try to solve it. Try to solve it. Try to solve this question. You solve it, or even if you are trying to solve, no, you send me the solution. I'll just check it that like how you are approaching it. Nothing, just approach it by the normal derivations. Okay, it is a very good question. Like 2023 paper was very easy only. Okay, but like this question was very good. Like in the exam hall only I saw this question, no, so I solved it. So I was like very happy in seeing this question. It was very intelligent, very good question. Like you solve after solving this question, no, you can understand the mentality of the gate. Okay, like the gate people, they just want to test your aptitude, your like problem solving skills. Okay, they don't want to give you रिवीजन करके सॉल्व करें. नहीं नहीं, इसको सॉल्व करना, अभी सॉल्व कर. क्या रिवीजन क्या है, नॉर्मल उसका बस नॉर्मली सॉल्व करना है इसको. दिक्कत हो तो बता, हम तेरे को डेरिवेशन दिखा देते हैं, उसमें क्या है. लो देख लो. ये डेरिवेशन देख लो. कुछ नहीं करना है, आई जस्ट टेल यू द स्टेप्स. यू फर्स्ट फाइंड आउट योर थीटा ए, then find out your theta b. Done. You have been said to find out the ratio between your theta a theta b. Understand what is said here. See, what is being said is what is being said is that your CO and H2 participate in a catalytic reaction. Okay, the partial pressures in ATM of the reacting species CO and H2 in the feed stream are PCO. The partial pressures are given as PCO and PH2. Okay, while CO undergoes molecular adsorption, H2 adsorbs via dissociative adsorption. Means what is going to happen is that this CO plus one vacant site will give you COS. Okay, this reaction will be happening. Okay, this adsorption will be happening. However, this H2 will take up two vacant sites and will give you 2HS. Okay, dissociative adsorption, that is as hydrogen atoms. Okay, it will not get like as a whole molecule, this H2. Okay, this will get as this dissociative, like H2HS. Okay, like this. Now what is said is that the equilibrium constants corresponding to this catalyst, it is KCO. So this KCO is simply what? Suppose this is no. So suppose this is your KCO. What about adsorption? And this is your KCO desorption. Okay. So capital KCO that is given is KCO adsorption and divided by KCO desorption. Clear? ओके. व्हाट इज योर दिस थिंग? इसको इसको क्या करें? ये क्या है? इसका क्या हो जाएगा? ये मान लो KH2 adsorption and divided by KH2 desorption. Okay. So it is given as capital KH2 that is equals to KH2 adsorption and divided by KH2 desorption. Okay. Now what is said in the question? It is said that total molar concentration of the active sites, total active sites is equals to CT. Okay. Total active sites is equals to CT. This is the total. Okay. So let this theta A, let this CO be A only. So let this theta A be representing, let this theta A represent this, the amount occupied by your CO. Okay. And let this theta B represent the amount occupied by these hydrogen atoms. Okay. Then it is said that one of the correct expression for the ratio of the catalyst size occupied by CO to that. That means you have to say theta A divided by theta H or theta B. This you have to find it out. This you have to find it out. So this much I have said it to you. Now solve it. अब सॉल्व करो. इतना तक तुम बना ही दिए भाई, अब तो सॉल्व कर लो. अब थोड़ा सा ट्राई कर लो. बताओ जल्दी होगा. ओके. हाइड्रोजन को मान लो बी है. ठीक है. हाइड्रोजन एटम्स को मान लो, हाइड्रोजन एटम्स को बी मान लो. ठीक है ना? अब बताओ होगा सॉल्व? ट्राई करो थोड़ा सा. बिट कंफ्यूजिंग? कुछ कंफ्यूजिंग नहीं है. व्हाई इट इज बिट कंफ्यूजिंग? यू टेल मी द वैल्यू ऑफ योर थीटा. दिस सी. क्या कंफ्यूजिंग लग रहा है भाई इसमें? ऐसा कंफ्यूजिंग लग रहा है, क्या बोले? लिख ले इसको, ऐसे ही लिख ले. लिख ले इसको, सीओ लिख ले. भाई कंफ्यूजिंग लग रहा है तो फिर गेट एग्जाम में भी कंफ्यूजिंग लग जाएगा. फिर खत्म, फिर तो कुछ नहीं हो पाएगा. ये लो, ऐसा है. अब तुमको बस थीटा सीओ बाई थीटा एच निकालना है. ये थीटा एच मान लो. ट्राई टू सॉल्व इट, ट्राई टू सॉल्व इट. आई गिव यू जस्ट 3 minutes more. अरे बनाओ भाई, इतना टाइम क्यों लग रहा है? कहाँ जाकर अटक रहा है बता। नहीं बनाओगे तो फिर बोलो, एंड करते हैं। देखो हम यहाँ तक कर देते हैं, उसके बाद फिर खुद कर लेना। सी है, so your rate of adsorption of CO, this will be is equals to KCO AD into 1 minus theta CO minus theta H and into minus theta CO minus theta H into PCO. Okay. Your rate of desorption of CO will be KCO into theta CO. Okay. Both the steps are in equilibrium, so just equate them. After equating them, you will be getting KCO AD PCO into 1 minus theta CO minus theta H. This will be is equals to KCO DE into theta CO. Okay, from here you will be getting KCO into PCO into 1 minus theta CO minus theta H is equals to theta CO. Okay, like this you will be getting. So 1 minus theta CO minus theta H, this can be equals to written as theta CO by KCO into PCO. Okay, as same as you that theta 1 minus theta minus theta b. Okay, the only difference will be in this thing. Okay, in this thing what is going to happen is that the rate of adsorption, this rate of adsorption will be is equals to KH2, sorry, KADH2 into vacant site, that is your 1 minus theta CO minus theta H. Okay, and into your partial pressure of H2, so PH2. ठीक है, and this will be whole square, and your rate of desorption, it is equals to KH2 DE into theta H whole square. Okay, so equate both of these. After you equate both of these, you will be getting KADH2 into minus theta CO minus theta H whole square into PH2. This will be is equals to KH2 DE into theta H whole square. Okay, so from here you will be getting your this KADH2 by KDEH2 into 1 minus theta CO minus theta H whole square into PH2 is equals to KH, sorry, this has gone that side, no, into just theta H whole square. Okay, so this is nothing but your KH2 PH2 and 1 minus theta CO minus theta H whole square, that will be equals to your theta H whole square. Okay, from this you just put root under, so 1 minus theta CO minus theta H will be is equals to theta H divided by root under KH2 PH2. Okay, we have just taken root under on both sides. Okay, so now this is only equals to your this thing, no, this is only equals to your this thing, that is your theta CO divided by KCO PCO. Okay, so from here you have been said to find out theta CO by theta H, and that will be is equals to KCO PCO divided by root under KH2 PH2. This will be your answer. क्या था इसमें? Nothing was there. The only thing was there is this thing. As because there is 2s present here, as because there is 2s present here, okay, as because there is 2s present here, so here you have to take that whole square, and as because there is 2hs present here, in the rate of desorption also you have to take theta h whole square. Nothing is there. Rest everything is same. Rest everything is same. Rest everything is same. Nothing was there. This is normal simply. Okay, this is normally just 1 minus theta a minus theta b. Okay, that is equals to theta a by ka p a. Okay, the only thing was there, that is your this b, this b was getting in this format. It is plus 2s. It was getting absorbed in 2bs. Okay, only this thing was happening. So as because this thing was happening, what we wrote it as, the forward reaction rate, we wrote it as uh, kaad, and into, for this b2 we will be having partial pressure of b2, and for this 2s we will be having 1 minus theta a minus theta b whole square. The backward reaction rate, sorry, this is b, so kbde into bs is there, so theta b whole square. Only this thing was there. Only this thing you would have, you have had to catch, that as because 2s is there, that's why we are doing 2s. This b2, for this we are writing this partial pressure, and for this we are putting here whole square. Just that thing was there, and simply we will get the answer. So see from where they have given this question. Okay, so how beautiful, like this question was very intelligent, very good question. This question was very good question. From the derivation they gave this question, from the derivation of this Langmuir Hinsel wood. You're getting it? Like, this was a very good question. From these concepts, from these concepts they gave this question. So good. ठीक है. Chalo. With this we have ended our heterogeneous part of our CRE. Okay. You can go and try to solve all the questions. Okay, now if you have solved this kind of questions, so all the questions, other questions, you will be able to solve it very easily. Okay, so we will end our class today here only. From tomorrow we will start our IPC. Okay, those who have joined, those who joined today for your IPC revision, very sorry, but still you have learned so many things new, no? That is also, this is also very important. सर अगर आप फ्री हो तो कल क्लास मॉर्निंग से शुरू करते हैं. नहीं ब्रो, कल मॉर्निंग से तो हम फ्री नहीं है. कल मॉर्निंग से हम फ्री नहीं है ब्रो. हम जब फ्री होते हैं तब भाई कुछ भी करके कोशिश करके अभी करा देते हैं भाई. देखो अभी आज टाइम मिला, ठीक है, तो हम टाइम वेस्ट थोड़ी किए भाई, करवा ही दिए तुमको. कल ही ट्रैवल करके आए हैं, ठीक है ना. ऐसा तो नहीं है भाई कि हम बैठ के रेस्ट ले रहे हैं. जितना टाइम मिल रहा है भाई आज भी तुमको करा ही दिए. 3 घंटा, 2 घंटा, 5 घंटा का क्लास तो करा ही दिया है. ठीक है, तो जब टाइम मिलता है भाई हम करा देते हैं, ऐसा तो नहीं है. ठीक है, बाकी कल भी देखते हैं. कल जब कल अगर आफ्टरनून तक फ्री हो जाते हैं तो फिर कल आफ्टरनून में क्लास एक कर सकते हैं आईपीसी का रिवीजन के लिए. ठीक ना. थोड़ा इवनिंग 7 तक देखते हैं, अगर 3 तक हम फ्री हो जाते हैं ना, 2 तक अगर फ्री हो जाते हैं तो फिर 3 से 7 तक करते हैं. ठीक है, क्योंकि हम चाह रहे हैं कि आईपीसी एंड हीट का रिवीजन खत्म कर दें. ओके, but anyways you don't be worried. Okay, you will have time on Thursday, we will have time, Friday we will have time. Okay, Saturday, 3 days are there. Friday, Saturday and Thursday, these 3 days will be there. Okay, tomorrow it may happen that your class is missed, but Thursday, Friday and Saturday you will be having time. Okay, then after that your Sunday and Monday we will go according to the plan. Okay, your Sunday and Monday maybe we will be having some time gap. Okay, and then I will be traveling, and after that we will start our class. Then we will start with FM. Okay, you Thursday, Friday, Saturday, no? Thursday, Friday, Saturday, these 3 days we will complete our IPC and our heat. Okay, and your CRE is over. Your MT is over. These were the main subjects, very important subjects, very conceptual subjects. Okay, numericals of these subjects are very difficult. Like very difficult means it is like a little bit complex to solve. This IPC and heat we will already cover it in this Thursday, Friday, Saturday. Maybe tomorrow, that is our Wednesday, we don't have a class. Wednesday, maybe we don't have a class. If it is possible, I will have it. If it is not possible, then maybe tomorrow we don't have a class. Okay, Thursday, Friday, Saturday, we complete our IPC and heat. Then after that, maybe Sunday, Monday, okay, Tuesday, some 3 4 days gap will be there. Okay, till 26th, 27th. Okay. Once after that, we will start from 28th and 20 or 29th. After from this, we will start, and then we will be like till that my relocation and everything will be completed. Okay, so from 28 and 29, we will start and we will complete everything. Like only our FM and thermo is left. Okay, this FM and thermo we will cover it by January 10. Okay, and then we will start our revision. Okay, these small subjects that PD, MO, and all these things we can do it after that. Okay. We will do some question practice sessions also. Okay, aptitude, for aptitude also I will take 2 3 sessions. Okay, for CT को भी करवा देंगे बढ़िया से. केमिकल टेक्नोलॉजी को भी लास्ट में वो जनवरी ये सब खत्म हो जाएगा ना, फिर जनवरी 20 के बाद सिटी भी रटवा देंगे पूरा. कोई दिक्कत नहीं है. ठीक है, अभी तुम लोग इसका सवाल वाल बना के इसको खत्म कर लो. ये सब मेजर सब्जेक्ट्स है, इसको बाद में करना दिक्कत होगा. ठीक ना, तो मेजर सब्जेक्ट्स को अभी खत्म कर लेते हैं, फिर उसके बाद वो सब करते रहेंगे. कोई बड़ा चीज नहीं है. ठीक है. ओके, चलो, वी विल एंड द क्लास हियर. Yeah, okay, thank you.